Hello. So today we are going to put together what we learned last week. I put out a movie about the basic atom parts that you would have need to watch. And then yesterday we also talked about what isotopes were. And there's a review video in the link above in case you still need to practice with some of those terms. Because you're going to be making a three-dimensional model using very simple items around your yard and house to model two or more different isotopes. So I'm just going to show you a few review things. Remember the isotope symbol. So on the periodic table, it just gives us the average mass, the AMU. But in order to make a model, we're going to have to know exactly for that atom, for that particular atom, how much does it weigh? How many neutrons does it have? So this is the isotope symbol. The mass number goes up here. So this A just can be any number. It's the number of protons and neutrons combined. That's the mass number. You put the atomic number at the bottom. So this is kind of reverse of the periodic table. So some people find it confusing. So just make sure you look at these pictures before you make the atoms I ask you to. So this is the atomic number down here. So here's an example. Here's hydrogen. It has atomic number 1. And this hydrogen, this particular hydrogen, has a mass number 3, which would mean it has 2 neutrons and 1 proton for a mass of 3. So here's another example without the A's and symbols. So we have potassium, that's what K is, the element symbol. Then we have the mass number at the top, which is the number of neutrons and protons. And we have the protons listed on the bottom, or the atomic number. Your protons is going to equal your neutrons. Your protons, take that back. Your protons are going to be equal to the number of electrons for a neutral atom, which is what we're going to deal with right now. So looking at this particular example, if the mass number is 39 and I subtract the number of protons from it, I get 20 neutrons. So that's how I can figure out how many neutrons I have. And I have 19 electrons because there's 19 protons. So just a couple more. What is an isotope? Remember, an isotope is an element, the same element with a different mass. So here's carbon 12. That's what we would call it. You call it by its mass number. Here's carbon 12, and it has 6 protons. That's why it's carbon, but it has a mass of 12. So could you tell me how many neutrons it has? And here we have carbon 13. That's what we would call it. It has 6 protons, but it has a mass of 13. So how many neutrons does this have? The answers were 6 neutrons here. 6 plus 6 is 12, and 7 neutrons here. So here is just an example of 3 different isotopes of carbon. They all have the same atomic number. They're all the same element. What is different is their mass number. So what I'm going to do is show you a couple videos of us making a 3-dimensional model, and Zeus is going to be my teaching assistant today. It's been a little harder to incorporate him in my lessons since we're not doing bridges and walking around. So you may notice with this kind of crazy lesson that maybe I'm getting a little home stir crazy and bored, but Zeus is going to help us learn about isotopes. So watch the couple videos and then you'll be making your own model. Thanks.
Okay, so now I'm going to show you how to make a model. So here is what sulfur would look like on the periodic table with atomic number 16 and a mass of 32.066. But if you're going to make a model, you have to know which particular sulfur atom to make. So we are going to make sulfur 34, 16. So the 16 is the atomic number and the 34 is the mass. The way I figure out my neutrons for my model is take 34 minus 16. So I have 18 neutrons. So if I come out here, I have to refocus a little bit. My camera doesn't automatically do it when I'm in movie mode. If I come out here, then what you'll see is I used rocks for my protons. So I have a key. You'll have to make a key. I use big rocks for my protons. My neutrons, missing a neutron. My neutrons are made with dog treats, and so I'm going to put that neutron back. And my electrons I just drew on, just because Zeus is going to be my assistant, and if I didn't draw them on, he would mess up my model. But in my second model, I will show you one that I did not draw on. So if you count my dog treats, I have 18 dog treats. I have 16 rocks for a total of 34. Now Zeus, hey Zeus, got to help us a lot with bridges, and he hasn't got to play much once we're studying dating. So come on over here, Zeus. You're going to make an isotope. Come here, Zeus. Make an isotope. So Zeus is going to come up and start making an isotope here. Okay, all done. Back to your bed. Back to your bed. We'll send Zeusy back to his bed and figure out. Here you go. Back to your bed. There you go. Good boy. Stay. Stay. Now we're going to figure out what isotope we have here. Do we still have sulfur? No. He's trying to come in and still eat. We still have sulfur because he didn't eat any of the rocks. So we still have 16 protons. So that means we have sulfur. But what we have to do is count the number of dog treats now to see what isotope we have. He ate a little faster than I thought. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to count one more time from up here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9. I counted 1 twice. So we only have 9 neutrons left. So how would we write that over here? Well, if I have 16 protons and only 9 neutrons, 16 plus 9, this would only be sulfur 25. So Zeus ate a lot of neutrons. Okay, Zeus, one more isotope. We'll let him finish up eating some more neutrons to make an isotope here. So he's making a new isotope, but so far he has eaten no rocks, so it is still sulfur. So we'll just give him one more moment to eat up his isotope. Okay, good boy. Come here. Come here. Over to your bed. Over to your bed. He's not wanting to go to his bed because, you know what? These isotopes are yummy. So let's go over here and see what we got left this time. We still have all 16 protons. It is still sulfur. But we only have 1, 2, 3, 4, 5 neutrons. And so he ate most of the neutrons. So how would we write that? Sulfur, 16, but we only have 5 neutrons, so the mass would only be 21. Now, there really isn't a sulfur that is that light, but I wanted to show to you that isotope is the same element, but what changes is the mass. So, Zeus, hey boo-boo, Zeus, sit. Hop off, hop off. Hop up, come on, hop up, hop up. Good boy. So, thank you for watching. We'll see if we can have Zeus catch the last through neutron. Ready? So this time, I'm going to make a less edible model. So I'm going to make lithium. So this is what lithium would look like on the periodic table with a mass of 6.941. But remember, you can't have part of a neutron. So I will give you the symbol, the isotope symbol. So I'm going to make this lithium, which would be called lithium-7. And so the 3 is the number of protons from the periodic table, atomic number 3, and the 7 is the mass. So you can make these models out of anything. So I went outside and I am making my model. Let me see if I can focus a little bit. I am making my model out of flower leaves or flower petals and flowers. So all you got to do is find something outside, preferably to make you walk around outside, or you can use something inside. You need 3 things: protons, neutrons, and electrons. And then you need a key. So in my key, my electrons are little blue flowers. My neutrons are the big red petals, and the protons are the positive petals. So the protons are the pink petals, sorry. So in my model, I am making lithium-7. So I've got 3 protons, 3 pink petals, but my total mass has got to be 7. So 7 minus 3 is 4. I need 4 neutrons. So there's my nucleus. You can count up and make sure the mass is the right. 1, 2, 3, 4, 5, 6, 7 petals. That's my mass. And then I have 3 little electrons. Let's see, the electrons are little blue flowers there that you see. So I have 3 electrons because I have 3 protons. So that is my lithium-7 atom with a key. But then right next to it, I'm going to make lithium-6. So how am I going to do that? Well, it's still going to have 3 protons, but it only has a mass of 6. So 6 minus 3, that means I must only have 3 neutrons in this atom. So I'm just going to add, whoops, can't add another proton. I'm going to add 3 more neutrons to my nucleus. So now I have 6 particles, 3 neutrons, 3 protons, for a mass of 6. And then I would have the same number of electrons. Those would not change. So I'll add my 1, 2, and 3 electrons, and I will use my same key. So here's the key I used before. This is lithium-6, and this is lithium-7. And then I could go on and make another model with rocks or sticks or grass or whatever I wanted to. So I will give you the symbols, and you will make 2 isotopes of the same model. Have fun.